within the PCNSE, and as within the PCNSA actually for that matter, you're going to be expected to understand high availability. So we're going to talk a lot about high availability now, because there are often some myths around it and there's some misconceptions around it, and there are specific use cases for it as well. So as you go, not only for your PCNSE, but as you go further forward for working with Palo Alto firewalls and working with customers and trying to provide the best you can for the customer, this is going to, I think this will be of benefit to you. Okay, so high availability clustering. Okay, so there's several models of Palo Alto firewalls support session state, and you can put this into a cluster of up to 16 firewalls. A cluster should never be confused with HA. So a lot of times people think the terms are interchangeable, but they're not actually. So there's a cluster and then there's HA. So the reason for this is because in a cluster you have several firewalls, as we can see, up to 16 firewalls that are designed specifically to all work together and all be seen as one firewall. Whereas within HA, you've got an active firewall and a passive firewall. So you've got all the traffic going to one firewall. Should that fail, then there's a second firewall there to pick it up. Now, high availability clustering uses the HA4 link, which is it says there's session synchronization, and you would only really sort of get into that for clustering. It's not used for anything else. The HA4 must be low latency though. It's got to be low latency, and asymmetric routing must be avoided. One of the biggest problems with clustering firewalls is asymmetric routing, and your routing really needs to be paid attention to. Firewalls can be added and removed from the cluster, something that is, I guess you would liken it to scale groups within cloud. Is in a cluster you can have a cluster of 5 or 6 firewalls, and you can add another one as you need to, or if one fails for hardware that can come out, the cluster will still keep going. You can add a firewall into the cluster. But by far the most used configuration is going to be active passive. That's the one you're going to see most of the time. And for active passive, you have 2 firewalls, and as the name suggests, one is active, one is passive. And so you have the throughput figures for the one firewall, and that doesn't become any kind of aggregate. There's no increase in throughput because you've got this active passive configuration. For Palo Alto Networks firewalls, it's supported in vWire, layer 2 and layer 3 modes. So you can configure it for those. So if you've got a virtual wire, so you have a bump in the wire essentially. If you've put your firewalls into a environment where there's no layer 3, it doesn't take part in the routing or anything like that. It's supported in that. For layer 2, so that you've got your routing and everything done. This is just on VLANs, VLAN throughs, and then layer 3 where it's routed. The session state between the firewalls ensure the active goes down, traffic keeps flowing. So you have HA2. HA2 synchronizes your session state. So as a session is started on the active firewall, that configuration, that connection is mirrored. The TCP state, the TCP sequence is all. So should the active firewall fail, then the passive can pick it up. As before, it uses the HA1 and HA2 links. HA1 is the control link, and HA2 is the data link. HA1 is layer 3, and HA2 is layer 2. So that's just something to bear in mind. HA3 is also a layer 2, I believe. But HA1 and HA2 is what you're going to use for this. So how does it actually work? So you have one or more monitor interfaces. As you monitor the interfaces, they are checked to see if they're up or down, see if there's anything wrong. And if so, it will then fail over. So if one interface goes down on one firewall, it will fail over to the other firewall. You can also monitor paths. So you've got destination unreachable. if you have a path monitoring on one side and the active firewall, although everything's fine, but suddenly it loses its path to the router, to the upstream router, or to its gateway, you can have a failover. You have heartbeat monitoring, so you have hello monitoring, which is heartbeat between the two. Should and this is configurable as well. So should the other firewall disappear for any reason, it misses the heartbeat or set number of heartbeats, and then you fail over. Next one obviously is component failure, so packet health monitoring. So if there's a component goes down, then again it fails over. So after this, you've got active. Now, one of the things about active is within the design of an active, not cluster, but it's not a failover pair. It's an active. Is a lot of people think it increases throughput, and in fact, actually, it does, because you are load sharing between the two. Yes, you have potentially you could burst to double the throughput of a single firewall. However, you do have to remember that should one of them fail, half that traffic's then going to get lost, because the second firewall, or the firewall that remains up, can't service all the traffic from the two firewalls. There are also a few caveats with it. It doesn't support DHCP relay, and it can require additional network architecture changes to avoid asymmetric routing, etc. But that said, once you've got that sorted and figured, it does handle, as we say, peak bursty traffic a lot better. So if you've got something that its baseline is within the capabilities of one firewall on its own, but occasionally or on a reasonably regular basis you occasionally have bursty traffic, then you're going to be able to go into that oversubscription based on the fact there's two firewalls. It does not support layer 2 mode, cannot receive addresses by DHCP because there is a floating IP address, and only the active primary can operate as a DHCP relay. The active secondary will drop receive DHCP broadcasts. This is all because you're going to have to be behind a floating IP across the two boxes, and so that you could see where that could become troublesome. As the name would suggest, we're going to start talking about the HA and stuff, and it's actually a bigger subject than possibly it may initially seem. So for the PCNSE, you're going to need to know some use cases, why you would use certain HA modes and why not, the inherent issues of HA modes, because although when you go through the study guide, it gives you an idea of what they might ask. I know for a fact that I encountered a few questions that were a bit more in depth than what they asked. Okay, so our first one, of course, is the one that you'll encounter most, which is active-passive. So you have one firewall active, one passive. Okay, and as a general rule, they will have, I'll use a different colour, so it's all good. So, as a general rule, for active-passive, you'd have HA1 link, which is the HA1 link is your control link. So that's the control link, and that is a layer 3 link. Then you have HA2, which is all your session states and everything like this, and that's the data link, and that's layer 2. If, however, the firewalls are across different subnets, that can actually become an IP link using UDP port 2950, I think it is. actually I will just check. 29281 is the port it uses. And these can have, as well, these can have, just get rid of that, and that, and they can have HA1 backup and HA2 backup. So you'll have links at the bottom as well on the diagram, of course, not necessarily in real life. So you have links as well at the bottom just in case these two fail, or either of these two fail. So when we start talking about a failure, well, what is a failure? Well, a failure, so in this particular instance, let's take this router out here and this router out here. Okay, and draw it as you'll normally see. So in a normal environment, you'd see, usually it hits, well actually what usually happens is this: you have a switch at the front which is known as your edge switch, then that'll have a router terminated there, so usually you've got layer 3 on there, or it'll have a router in front of it, and then your firewalls will connect into there. Okay, so for the active passive mode, you've literally got, say this one is 1.1.1.1, that'll be 1.1.1.2, and in the event of a failover, this will stop doing anything, and this one will then send out a gratuitous ARP to update the ARP table on here that now has the IP address. And that can be as a result of several things. Actually, what am I doing? Result of several things. So let's just say this all is well. All is well. And our traffic's flowing really happily, and there's cat videos and everything being watched down here. And then you have these uplinks, so that could be ETH 1/1, which is my favourite uplink. So these are what's known as monitored interfaces. So these interfaces are monitored. Should anything happen to these interfaces, that will cause a failover. Okay, you have a heartbeat that runs across here. Should the active firewall stop responding to the heartbeat, again, the passive will take over. And then they have packet health monitoring, which is then looking at the devices. So any physical part of this firewall fails, then it'll notify that one, and that one will take over. And of course, you have got cessation of links and so on. If the control link goes, and that control link goes, then that one will take over. See, that really is then, and I mean this works as well the other way, so you'd have your edge switch, then you'd have your, that's really badly drawn, so then you've got your internal switch. And then the interface is coming down here, so ETH 1/2, ETH 1/2. Again, based on the fact that you've been monitoring the interfaces, there's no point, if this is all up, but this one goes, there's no point the firewalls remaining like this, because this one's not doing anything, and the packets now, they can come down here, that's all good, but they can't get here. So again, this one would take over as the active, so that then the path is restored. The thing with active passive is that really it's kind of teaching you to suck eggs, because all active passive pretty much works the same way. It's a gratuitous ARP up or down, So if this link goes, there'll be a gratuitous ARP that way, so there'll be a GARP, which is basically telling this one that the IP of this side, so if this side was 2.2.2.1 and 2.2.2.1 as the gateway, so if we've got a host here, and his gateway is 2.2.1, that switch knows how to get there, so that switch knows where the MAC address is of 2.2.1. Whilst that one's active, it's owned by that firewall, and when that firewall falls over, which doesn't happen in Palo Alto, by the way, when that firewall falls over, this one will take over till that switch. Okay, that IP address is now at this MAC address here. Okay, so that's active passive. That's pretty much it in a nutshell. Here we have, in this particular instance, what we've got is we're going to have a router instead of a switch. So we're going to have two routers here. These routers have both got a path into the internet. And so we've got redundancy running between the two of them, which would probably be BGP in this particular instance. And then what we need to do is we need to make sure that underneath those we have best path selection and all the good stuff that goes with dynamic routing has got to be able to be taken care of by the firewalls. So underneath we have our two firewalls. And these are going to be active. And for this we're going to have no floating IP addresses, so we just have connectivity into here, and running between firewall and these routers will be either BGP, OSPF, or some other dynamic routing. And these will be configured with separate IP addresses, no floating IP addresses here, so they can have separate IP addresses. So this is 1.1.1.1, 1.1.1.2. And so now we have our routing going through there, hitting both of these. And of course, in order to configure this, we're going to need three HA links. So we have our HA1, which, as you remember, is our control link. HA2, which is our data link, and HA3, which is our packet forwarding link. So HA3, if a packet hits this, but the owner for that is this, then that has to be able to move that packet across there so this firewall can handle it. So the HA3 link really does have to be quite a big link. It has to be able to handle all the traffic that is potentially going to come down to these two firewalls. In the event of a failover or an interface becoming unavailable or something like that, that redundancy then is handled by the routing protocol. So if this link then goes, where's my little rubber? This link then goes for some reason, then BGP will know that it has a path to the network down here, this way. And then using the routing protocols, using their own recovery mechanisms, when this comes back up, then BGP knows that it has two paths to the advertised network underneath. Okay, so that's active without floating IPs. So I think it's a good way of doing it. I think it's ideal in a way, and of course you get the resilience. You also there's some other advantages as well. So you can allow your routing protocol to look at the link quality between the two. So if one becomes congested, obviously it will prefer the other route, then it will go down the other route. And you have got a very, very quick failover between two. Again, as said previously, always remember that these aren't then aggregated. So this box, so if this can handle 1 gig, and this can handle 1 gig, which should be able to handle more than that, but fair enough. Right, so technically speaking, you could get 2 gig through that, but if this one fails, you can't get 2 gig, because that obviously then, this firewall can still only handle 1 gigabit per second. So that's important to remember. Okay, so the next one is going to be active-active using floating IPs. Our routers, edge routers there. Then we have edge switching infrastructure. So these are routers. I know that's not standard. What's the word? Iconography. And then switch 1, switch 2. As a general rule, to provide all the redundancy that we need, these would then be connected thus. Okay? And then underneath, we're going to have our firewalls. Bloody hell, what's that, Dad? Not entirely sure what I'm drawing there, lads and lasses. Right, so we've got active-actives. This is firewall 1, firewall 2. Active. Okay, then underneath this, so this, that, which is going to give you more redundancy, and I think it's arguable to say you'd ever need in a million years, but you know. And then underneath you'd have your internal or LAN switch 1, switch 2, LAN infrastructure. So the concept of the floating IP provides a lot of different actual advantages. Okay, so one of the advantages you've got the floating IP is that if we have, let me just pick another colour here. So if this is 1.1.1.1, that's its physical address, 1.1.1.2, you would only be able to, or you can use this one or this one. If you put a floating IP in between them, then obviously you then have that resiliency based on that, but that's active-passive. So in an active-active situation, what we do then is we have another IP. So we've got floating IP for this one, so that's going to be 192.168.1.1, and floating IP for this one, 192.168.1.2. Okay, and we're going to draw some little hosts in at the bottom because I think they're important. So here's our little host and another one. Try and draw them the same so I don't look so foolish. Okay, so that's going to be host 1, LAN 1, and that can be host 1 on LAN 2, for instance. Not LAN question mark, because that would be daft. Okay, so then they're connected into these switches. My orange pen doing a fantastic impression there of a black pen. I think that one might be knackered. In fact, actually, to that end, I think that could be my fault. Okay, right, so with this now, so this firewall has ownership of this floating IP and this firewall has ownership of this floating IP. Should this one fail, then this firewall will reply for both. But there's many things you can do here now. So if you want to load balance across the two firewalls, and you're going to use this boundary of networks to do it, then you could quite easily have these ones going there, these ones going there. But by virtue of this redundancy here, if this fails, then that will answer for both. And we still have the issue with the ability for the throughput, but I mean, you're going to size the firewalls correctly anyway, so I'm going to stop saying that now because frankly it's getting boring. So, and this works the other way around as well, so you can load balance across the traffic coming in. So essentially that's what the floating IP is for. So anything happens here, this one will take over, or again anything happens there, that one will take over, but until then you've got those two paths in. And up here you can create your routes, so you can prefer one route, so prefer that firewall 1, and then as a backup it's got firewall 2, or you can do ECMP, which is equal cost multipath between the two, where you have an equal cost from here to either, and then again handled at the bottom here you've then got your floating IP again, where if one goes down the one firewall will answer for both. So you can see actually you not only have you built in a mechanism by which you can load balance to your heart's content frankly across the firewalls, but also you've got multipathing coming in, you've got the ability to use your dynamic routing in order to ensure that you've got path availability. Traditional type of failover, so instead of having the two floating IPs, you've got the one floating IP. So in this particular instance, let's just say that, let's give these some IP addresses at the top. Let's be really, really original. So 2.2.1 and 2.2.2.1, and then we're going to give it a floating IP. Are you ready for this? Of 3.3.3.1. I'm dynamite, absolute dynamite. And we'll give this a floating IP just to try and prove that I'm relatively random. 4.4.4.1. Okay, so floating IP and the orange pen's coming back, which is awesome. So floating IPs, then the ARP is where that's load balanced across, and you can create a situation where they will share that ARP between the pair of them, and should this one fail, then obviously that's already there, and should that one fail, that's already there. Okay, it's also important to remember, of course, that with the floating IPs, there's also a mountain of things that can be tuned and configured to what you need within your environment. But also, importantly, this then allows you to do things like NAT across it, DHCP, and you can tie down, so you can tell this firewall the algorithms that control this section here done on the firewall, where you can sort of tie ARP to one firewall. You can tie the ARP to one firewall depending on which one you want. You can set priorities to control the amount of traffic flowing between one firewall and another firewall. And again, this uses the HA3 and 4 links. And there's an algorithm that runs as well, which does some hashing between the IP address and the MAC address and so on to actually place it where it's going to be. It's very, very involved, I would say, but ultimately customizable as far as you want it. So those are your options. You have, so let me get rid of all this. sort out my OCD there, making sure it's all rubbed up. So those are your options. So your options are active, passive, and that is HA1, HA2, active, active, spelled wrong. And that is HA1, HA2 and HA3 links. And if you remember, a HA1 link is our control link, and that is layer 3, layer 3, HA2 is our data link, session link, and that is layer 2, but can be configured layer 3, and then HA3 is for, because these, if you remember, are for active passive. Those are for active active, and this is our packet forwarding link. Between the two firewalls. So that's pretty much HA. I appreciate your time. Obviously, like and subscribe, or don't. And yeah, that's HA.